Welcome to the session number 14 from the playlist of current electricity. The topic for the today's session is the Kirchhoff's loop rule and the junction rule. And based on this topic, I have selected one question from one of my reference books for this session. Here the question is, find the current through the 1 ohm resistor. So this is an electrical circuit which comprises the EMF sources and few resistors as shown in this figure, and we have to find the current through this 1 ohm resistor. This is the 1 ohm resistor, and we have to find the current which is flowing through this resistor. So before proceeding further, let's revise the Kirchhoff's loop rule and the junction rule. So the Kirchhoff's loop rule says that the algebraic sum of the potential difference across all the EMF sources and the resistors in an electrical circuit should be equal to 0, and the Kirchhoff's junction rule says that the sum of the incoming currents should be equal to the sum of the outgoing currents at any junction in an electrical circuit. So in this question, what I will be doing is I will be taking the direction of flow of the current randomly, and to start with, let us consider that the current is flowing in this direction through this EMF source. We can also take the direction of the flow of the current opposite to this direction which we have taken. It can be taken in the opposite direction also. And if the direction of the current selected by us is wrong, or it is opposite to the actual flow of the direction of the current, then in that case the numerical value which we will be getting will be accompanied by a negative sign. So I am considering here that a current, say I1, is flowing across this EMF source, and so this current will also be flowing, the same current will also flow across this 3 ohm resistor. Now this current I1 gets divided into two parts at this junction. So let us say the current which is flowing through this 1 ohm resistor is, let us say it is I2, and the current which is flowing through this 3 ohm resistor is I3. So as per the junction rule, this I1 will be equal to I2 plus I3. So this is the first equation which we have got with the help of the junction rule. Now let us consider the loop AEFDA. AEFDA. So in this loop, this current I1 is flowing in this direction as shown by this arrow. Now this the potential difference across this EMF source will be taken as negative, because the current is flowing from a lower potential to a higher potential. Let us say this is a point. This is a point. These are the 2 points across this EMF source. So this will be at a higher potential and this will be at a lower potential. So the potential difference across this EMF source will be positive. So the potential difference across this EMF source will be positive, and so I have written it as 6. Now this current is I1 is flowing through this 3 ohm resistor. Now the potential difference across this resistor will be negative, because this is at a higher potential and this is at a lower potential. So the potential difference across this 3 ohm resistor will equal to 3I1. Similar, and now this in this loop, the potential difference across this 1 ohm resistor will be equal to I2. It will be minus I2. Sorry, it will be minus I2, because this is at a higher potential and this is at a lower potential. These are 2 points across this 1 ohm resistor. So this point will be at a higher potential and this point will be at a lower potential. So the potential difference across this 1 ohm resistor will be negative. So this will be equal to minus I2, and so this will be equal to 0. So this is the first equation. So this is the second equation which I have got with the help of the Kirchhoff's loop rule. Now consider the loop EBCFE BCFE. Okay, now here the this I3 current is flowing through this EMF source having a value of 9 volts, and so for this loop, the potential difference across this EMF source will be positive, that is, it will be equal to 9. The potential difference across this 2 ohm resistor will be negative because this is at a higher potential and this point will be at a lower potential. So this will be equal to minus 2I3 because the current which is flowing here, this is I3 here. So this is the current I3 which is flowing in this circuit. So the current which is flowing through this 2 ohm resistor will also be equal to I3. Now the current which is flowing through this 3 ohm resistor is also I3, and the potential difference across this 3 ohm resistor will also be minus 3I3 because this is at a higher potential, this point is at a higher potential, and this point is at a lower potential. So, and now in this loop EBCFE, the direction of flow of the current I2 across this 1 ohm resistor is opposite to the direction of flow of the current across this 3 ohm resistor, this EMF source, and this 2 ohm resistor. So the potential difference across this 1 ohm resistor will be taken as positive, and this will be equal to simply I2, and this will be equal to 0, and this is the third equation which I have got. So this is equal to 9 minus 5I3 plus I2, and this is equal to 0. Now we are supposed to find the value of I2 here. So what I will be doing is I will be simply substituting the value of this I1 as I2 plus I3 in the equation number 2. So from the equation number 2 and 1, I will be getting 6 minus 3. Now I1 is equal to I2 plus I3. Yes, minus I2, and this is equal to 0. So it implies that 6 minus 3I2 and minus I2 is equal to 4I2 minus 3I3. This is equal to 0. So let us take this as equation number 4. Okay. Now from this equation number 3, this equation number 3 can also be written as 9 minus 5. I have already written it here. Okay. So so from this equation number 3 and equation number 4, I will get 5I3 minus I2. This is equal to 9. So this is the equation which I have got from the equation number 3. That is, I have simply taken these two values on the right hand side of this equation. Similarly, from the equation number 4, I will be getting 4I2 plus 3I3. This is equal to 6. So what I will be doing is not consider this equation number as 5 and consider this equation number as 6. So from this equation number 5 and 6, I am getting what I will be doing is I will be simply multiplying this equation number 5 by 4. So I will be getting 20I3 minus 4I2. This is equal to 9 into 4 is equal to 36. I have multiplied this equation number 5 by 4. And the equation number 6 is 4I2 plus 3I3. This is equal to 6. So if I add these two equations, what I will be getting is, since this 4I2 and 4I2 will get cancelled out, so I will be getting just 23I3 is equal to 42. So it implies that I3 will be equal to 42 divided by 23. So this is roughly equal to 1.826. So the current 1.826 ampere. So the current which is flowing through this 2 ohm resistor, or you can say the current which is flowing through this 9 volt EMF source is equal to 1.826 ampere. But we have to find the value of the current which is flowing through the 1 ohm resistor, this one. That is, we have to find the value of I2. So if I substitute this value of I3 in the equation number 5, I will be getting 5 multiplied by 1.826 minus I2 is equal to 9. So I2 will be equal to, now 5 into 1.826 minus, 1.826 into 5. This is equal to 9.13. 9.13 minus 9. So this is equal to minus 0.13 ampere. So the current which is flowing through this 1 ohm resistor is equal to minus 0.13 ampere. The minus sign, so what does the minus sign means? The minus sign simply says that the direction of the current is from E to F, not from F to E, which we have taken. Here we can see the direction of the current which I have taken is from F to E. But since I am getting a negative sign here in the magnitude of this this current through this 1 ohm resistor, therefore the direction of the current will be from E to F, and its magnitude is equal to 0.13 ampere. So simply we can write that the current through 1 ohm resistor is 0.13 ampere, and its direction of flow is from E to F. Okay, so the actual direction of the current which is flowing across this 1 ohm resistor is from E to F, and its magnitude is equal to 0.13 ampere. So thank you very much for joining this session. In the next session, I will be coming up with another question. It will be a different type of a question. The topic will remain the same and the chapter will also remain the same, that is the current electricity. So till then, have a nice day. Bye.